According to National Electrical Code Section 422.16c, a double oven that may be used independently requires two separate circuits. This is to ensure that both ovens can operate simultaneously without overloading the electrical system. The ampacity for a double-stack oven varies depending on the specific model and its wattage. However, typically, a double-stack oven requires a dedicated circuit with an ampacity of 30 amps. National Electrical Code Section 210.52c requires junction boxes for appliances to be located within 12 inches of the appliance. However, inspectors may allow for some flexibility in this requirement. The inspector may be recommending placing the junction box 48 inches behind the oven for the following reasons. Firstly, accessibility. This placement allows an electrician to easily access the box for future maintenance or repairs. Secondly, clearance. It ensures that the box is not obstructed by the oven's cabinetry or other appliances. Thirdly, wire management. This distance provides ample space for wires to be properly managed and secured. Use American wire gauge number 10 copper wire for the 30 amp circuit. Enclose the wires in conduit or wire molding to protect them from damage. Install a 30 amp double pole circuit breaker in the electrical panel to protect the circuit. Although not required by code, consider installing a ground fault circuit interrupter outlet to provide additional protection against electrical shock. To meet code requirements and ensure safe operation, you will need to install two junction boxes for a double stack oven, each serving a dedicated 30 amp circuit. The boxes should be placed approximately 48 inches behind the oven for accessibility and proper wire management. When dealing with electrical installations, strict adherence to the National Electrical Code and local regulations is crucial for safety and compliance. Understanding the specific requirements for appliances like double ovens ensures proper functionality and minimizes the risk of electrical hazards. The NEC provides detailed guidelines on circuit sizing, wiring methods, and equipment placement to safeguard both property and individuals. In the case of a double oven, the requirement for two separate circuits stems from the potential for both ovens to operate simultaneously, drawing a significant amount of power. Without separate circuits, the electrical system could become overloaded, leading to trip breakers, damaged wiring, or even fires. Therefore, the NEC mandates that each oven be supplied by its own dedicated circuit capable of handling its individual power demands. Determining the appropriate ampacity for these circuits involves considering the wattage rating of each oven. The wattage rating indicates the amount of power the oven consumes during operation. By dividing the wattage by the voltage of the electrical system, typically 120 volts or 240 volts in residential settings, you can calculate the current draw in amps. It's essential to consult the oven's nameplate or manufacturer's specifications to obtain the accurate wattage rating. Once the ampacity is determined, the appropriate wire size and circuit breaker can be selected. The NEC provides tables that correlate wire size with ampacity, ensuring that the wire is capable of safely carrying the intended current. Similarly, the circuit breaker should be sized to protect the circuit from overcurrent conditions, tripping and interrupting the flow of electricity when the current exceeds the breaker's rating. In addition to circuit sizing and wiring, the placement of junction boxes plays a critical role in ensuring accessibility and safety. Junction boxes serve as enclosures for wire connections, providing a secure and protected environment for electrical splices. The NEC specifies that junction boxes should be readily accessible, allowing for easy inspection, maintenance, and repairs. While the NEC generally requires junction boxes to be located within 12 inches of the appliance they serve, inspectors may exercise some discretion based on specific circumstances. In the case of a double oven, placing the junction boxes 48 inches behind the appliance may be deemed acceptable if it provides better accessibility, clearance, and wire management. Accessibility is paramount for future maintenance and repairs. Placing the junction boxes in a location where electricians can easily reach them without having to disassemble or move the oven streamlines the troubleshooting and repair process. Clearance is also an important consideration. The junction boxes should be positioned so that they are not obstructed by the oven's cabinetry, countertops, or other appliances. Adequate clearance ensures that the boxes can be opened and accessed without difficulty. Wire management is another factor that influences junction box placement. The wires connecting the oven to the electrical system should be properly managed and secured to prevent strain, damage, or accidental contact. Placing the junction boxes 48 inches behind the oven provides ample space for routing and securing the wires, minimizing the risk of electrical hazards. When installing the wiring for a double oven, it's essential to use the correct wire size and type. For a 30 amp circuit, American wire gauge number 10 copper wire is typically recommended. Copper wire offers excellent conductivity and durability, making it suitable for electrical applications. To protect the wires from physical damage, they should be enclosed in conduit or wire molding. Conduit provides a rigid and protective pathway for the wires, shielding them from abrasion, impact, and moisture. Wire molding offers a more flexible and aesthetic solution for concealing wires, particularly in exposed areas. In addition to the basic wiring requirements, consider installing a ground fault circuit interrupter outlet for added protection. A ground fault circuit interrupter is a safety device that detects ground faults, which occur when electricity leaks outside of its intended path. Ground fault circuit interrupter outlets are designed to quickly interrupt the flow of electricity when a ground fault is detected, minimizing the risk of electrical shock. While ground fault circuit interrupter protection may not be required by code for all double oven installations, it's a prudent safety measure, especially in kitchens where water and electricity are often in close proximity. By following these guidelines and adhering to the NEC and local regulations, you can ensure a safe and compliant electrical installation for your double oven. Remember to consult with a qualified electrician if you have any questions or concerns. Working with electricity can be hazardous, and it's always best to seek professional assistance when needed. The dual circuit requirement for double ovens is a crucial safety measure that prevents electrical overloads and ensures the proper operation of both ovens simultaneously. Each oven must have its own dedicated 30 amp circuit wired with American wire gauge number 10 copper wire and protected by a double pole circuit breaker. While the National Electrical Code typically requires junction boxes to be located within 12 inches of the appliance, an inspector may allow for a greater distance, such as 48 inches, to improve accessibility, clearance, and wire management. Always enclose the wires in conduit or wire molding for added protection, and consider installing a ground fault circuit interrupter outlet to minimize the risk of electrical shock. The National Electrical Code is the cornerstone of electrical safety in the United States, providing comprehensive guidelines for the safe installation and operation of electrical systems. It is developed and maintained by the National Fire Protection Association, a non-profit organization dedicated to reducing fire and other hazards. The National Electrical Code is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Compliance with the National Electrical Code is essential for protecting people and property from electrical hazards. It ensures that electrical systems are installed correctly, maintained properly, and operated safely. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for various types of electrical systems, from residential wiring to industrial power distribution. The National Electrical Code is not a law itself, but it is often adopted by state and local governments as part of their building codes. This makes compliance with the National Electrical Code mandatory in many jurisdictions. In addition to the National Electrical Code, local electrical codes may also apply. These codes may be more stringent than the National Electrical Code, reflecting specific local conditions or concerns. It is important to consult with local authorities to determine which electrical codes apply in your area. Electrical inspections are an important part of ensuring compliance with the National Electrical Code and local electrical codes. Electrical inspectors are trained professionals who examine electrical installations to identify any code violations or safety hazards. Electrical inspections are typically required for new construction, renovations, and additions to existing electrical systems. Inspectors may also conduct periodic inspections of existing electrical systems to ensure that they are being maintained properly. If an electrical inspection reveals any code violations or safety hazards, the property owner is typically required to correct them. Failure to correct these violations can result in fines, penalties, or even disconnection of electrical service. The National Electrical Code is a complex and comprehensive document, and it can be challenging to understand and apply. If you are not a qualified electrician, it is best to consult with a professional for assistance with electrical installations and repairs. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. Always turn off the power to a circuit before working on it, and use appropriate safety equipment, such as insulated tools and gloves. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Electrical safety is everyone's responsibility. By following the National Electrical Code and taking appropriate safety precautions, we can all help to prevent electrical accidents and protect people and property from harm. The requirement for 2 separate circuits for a double oven is a prime example of how the National Electrical Code prioritizes safety. By ensuring that each oven has its own dedicated circuit, the risk of overloading the electrical system is minimized, reducing the potential for fires and other hazards. The National Electrical Code is not just a set of rules and regulations, it is a commitment to safety and a dedication to protecting the public from electrical harm. By following the National Electrical Code, we can all contribute to a safer and more reliable electrical system. Always consult the latest edition of the National Electrical Code and local electrical codes for the most up-to-date requirements. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. The National Electrical Code is a living document that is constantly evolving to meet the changing needs of the electrical industry. It is important to stay informed about the latest updates and revisions to ensure that your electrical installations are safe and compliant. The National Electrical Code is a valuable resource for electricians, contractors, inspectors, and anyone else who works with electricity. It provides the information and guidance needed to design, install, and maintain safe and reliable electrical systems. The National Electrical Code is a testament to the power of collaboration and the importance of safety. It is the result of the collective efforts of experts from across the electrical industry, all working together to create a safer and more reliable electrical system for everyone. Remember that electrical work can be dangerous and should only be performed by qualified professionals. If you are not a qualified electrician, it is best to consult with a professional for assistance with electrical installations and repairs. Safety should always be your top priority when working with electricity. By following the National Electrical Code and taking appropriate safety precautions, you can protect yourself and others from electrical hazards. The National Electrical Code is a valuable tool for ensuring electrical safety, but it is not a substitute for common sense and good judgment. Always be aware of your surroundings and take appropriate precautions to avoid electrical accidents.